the quick recap on position versus time graphs and velocity versus time graphs. Remember that in a position versus time graph, the slope of the position versus time graph is the velocity. The slope of a position versus time graph is velocity. So if we go and look at this one where we have constant position, well, first thing you need to do is check what your axes are on the graph. In this case, we've got position versus time. So if we have a constant position and then we have position on this axis, that means the position's not changing. So it's going to be a flat line. It might look like this, or it could be down here, or if their position was at 0 meters, then it would be down here. In any case, it's flat. And the reason it's flat is because there's no slope, which means no velocity, which means it's not moving anywhere. It's got a constant position, it's not moving anywhere, so it's got no slope. If it were moving, it might have a positive or negative velocity. So in this case, let's start with positive velocity. Again, check our axes. It's position and time, not velocity. So position and time, that means the slope, which is velocity, has to be a positive slope. So a positive slope might look something like this. It could also be starting up here, depending on what position they start at. In any case, the slope is positive because we have a positive velocity. So the slope is positive, that means it goes upward. That's the opposite of a constant negative velocity. By the way, it's constant because the slope is constant. The slope doesn't change the whole time. The slope is not changing here. If the slope changed, that means the velocity would be changing, not constant. So here's a constant negative velocity. It would look something like this, sloping downward. Again, because the slope of a position versus time graph is the velocity, and so we need a slope that goes downward in order to have a negative velocity. Now what if the velocity was not constant? What if we were speeding up? So let's assume we're starting with some sort of a positive velocity, and then we're going to a higher velocity. So a positive velocity might look like this, but then if it's speeding up, that means it's going to get steeper and steeper. So it's actually going to curve upward. Because if you look at the slope at any one point, in the beginning the slope is positive, but it's fairly shallow. As you get farther along, the slope is still positive, but it's going up at a higher rate. Since the slope is velocity, if we're speeding up, we're going to get a higher and higher velocity, really a higher and higher speed. But in this case, since it's positive, it's going to just go steeper and steeper. So speeding up means steeper. If we were slowing down, it would be the opposite case. Slowing down means our speed is getting smaller, which means our slope is getting smaller and more flat. So we might be going up with some velocity, and maybe it's kind of steep in the beginning, but over time that velocity gets more and more shallow. So the steep part in the beginning means that it's got a higher speed, and later on when it's flat, that means it's slowed down. If it was completely flat, then it would be going 0 meters per second, which is the slowest you can go. You're not going anywhere. So that's position versus time graphs. Remember, the slope of a position versus time graph is velocity. For a velocity versus time graph, the slope of a velocity versus time graph is acceleration. So, if we've got a velocity versus time graph, notice now the axis says velocity and time. Before it was position and time, now it says velocity and time. If we have a constant position, that means we're not moving. If we're not moving, that means the velocity is 0. So this whole time the velocity must be 0, like that. If, however, we are moving with a constant positive velocity, well, this is our velocity axis. So if it's a constant velocity, that means whatever value we have is going to be constant. It's going to be the same. If it's a positive value, it means we're up here somewhere. So it could look something like that, or maybe it's down here, or maybe it's up here, but it has to be above the time axis. If it's a constant negative velocity, again, the velocity axis is on the vertical axis here, but now we have a negative velocity. That means we're down here, and if it's constant, it means it's the same value, so it's flat all the way across. It could be like that, or like that, but definitely has to be below the time axis. If we have constant positive acceleration, then that means the slope, because acceleration is the slope of a velocity versus time graph, the slope has to be positive. So it might look something like this. That's a constant slope, and it's positive, it's going up, so the acceleration is constant and positive. A constant negative acceleration might look something like this. Notice in the beginning the velocity is positive because it's not saying that our velocity is positive or negative. It doesn't say anything about the velocity. All it says is that the velocity is changing toward the negative. The slope is negative. It doesn't mean the velocity has to be negative. It is down here, but not up here. What's negative is the slope.